Hi, good day and greetings. My name is Mr. Spinks. Mr. Spinks, and as I tell my students, those who are having difficulty pronouncing it, all that you have to remember is that we have the word pink with S's at both ends. So therefore that will give you Spinks. Nice having you here, and I look forward to us engaging, right, so that you can get a better understanding of who I am and what I have to offer, right? I have an ad up in pin.tt, and actually I'm doing this video for that advertisement, right? I am actually targeting students of Form 5 and those who are Form 4 who are writing the exam in June of this year and who would like an intensive session dealing specifically with past paper type questions and really getting into quick ways of answering some of these questions so that you will be in a better position to do well in the upcoming exam. So without further ado, let us begin. All that I'm going to do really is just give you a little idea of my techniques, what I do and how I do it, right? So I'm going to start looking at some areas that most likely you're already familiar with, but just to kind of give you a little perspective on that, right? So let's start with functions, right? So, okay, I'm going to write let f of x be equal to 2x plus 3, right? So f of x is equal to 2x plus 3. And we know that CXC loves to ask you to find the inverse. So let's suppose that we have to find, and the inverse is written f, the -1 as a superscript here, of x. To find f inverse of x. Now, what does f inverse of x do really? F inverse of x, actually, if you look at this kind of diagram here, right? Where this is domain, this is the range value, instead of domain values, range values. I'm assuming that you're familiar with that. So we call this here domain values, here we call this range values, right? So f will function this way. F will take values from here and map them to this side. F inverse on the other hand, will take values from here and map them onto this side here, right? So it will take this value here, and after going through a set of processes, you will get the value here that was actually mapped onto this. So this is what the inverse function really does. So if we have to find the inverse of this function here, what have you learned concerning this? Most teachers will tell the students, okay, follow this method. Let y be equals 2x plus 3. Is this sounding familiar? And then we say we interchange x and y. Interchanging x and y, we end up with x is equal to 2y plus 3. And then, of course, you make y the subject, right? So y the subject will produce y equals to x minus 3. Don't follow exactly what I'm saying. X minus 3, because I have to get rid of this 3 here, all over 2, because I'm multiplying by 2 here, so I divide by 2 there. And therefore, I have f inverse of x is equal to x minus 3 over 2. Now, for this, CXC will give you how many marks? 2 marks. CXC will just give you 2 marks for this, doing all of this working. To me, that doesn't make any sense, right? That doesn't make any sense. What I prefer you do is just follow a simple little method, a simple method that would allow you to get this answer here by doing something that is very, very simple. So what I will do, right next to this here, I will write that method. Right next to that. Now watch what I'm going to do here. All that I'm going to do is establish, starting with x, what are the operations that are done on that. right? So what's the first thing that is done? We multiply by 2, right? And for this here, we get what? 2x. So if we start with x here, we multiply by 2, we get 2x, right? Let me just write that slightly differently so as not to confuse you with all these. Right, let me just write that slightly differently. Right, so I have, okay, I start with x, put a little box there. The operation will go here. I multiply by 2, so I get what? 2x, right? Then what do I do next? What I do next is that I add 3. So I get what? 2x plus 3. 2x plus 3. So therefore, this is what f does here. So f will for these processes here. What does the f inverse of x follow? F inverse of x then will just do the reverse of that. So then, what did I do here? I added 3, so I must subtract 3 here. What did I do here? I multiply by 2, so I must divide by 2 here, right? So if I start with x here, on this side, now note that I can start with anything. It doesn't necessarily have to be x. It could be a, y, but just to remain consistent with this x thing here, I just put x there, right? X is simply a dummy variable in both cases here, right? So if I have x here, what do? I minus 3, so I end up with what? X minus 3 in a box, right? Then what do I do next? I divide by 2. So I end up with x minus 3 all over 2, which is the same answer as this. Same answer as that, without having to go through all of this. Now, eventually, what will happen is that you will be able to figure out this in one step. So you can move from here straight to the answer. Now, CXC will not penalize you for that because how the question is asked, state f inverse of x or write f inverse of x. So they don't really expect you to do a set of working for that, right? So based on how they ask the question, you will know how to proceed. So in this particular case here, right, they will tell you, write the inverse, f inverse of x, 2 marks. All you have to establish is what is being done here. What is being done first, I multiply by 2. Second, I add 3. So then if I had to reverse that, I must subtract the 3 and then divide by 2. All right? So with that in mind, let's just look at this simple one here. Let's look at this simple one here. G of x. Let g of x be equal to x squared plus 1. Right? You can see on the side, x squared plus 1. Now, if I have to write g inverse of x, what will I write? G inverse of x will be equal to what? What is done first? I squared, right? So I can write that here. I squared. What is done second? I add 1. Okay? So then if I have to reverse, I reverse in this one first. Right? Can I see that there? All right, let me just put that on top, on the side. So I'll just erase this here and just write it on the side here because I think I have gone past my boundary point. All right. So then, what is done first? I would have squared it. And then the next thing is I would have added 1. Right? So then if I have to reverse this, I have to subtract 1 and I have to take the square root. So how simple that is? Subtract 1 and take the square root. So then what will my answer be? If I start with x here, right? If I start with x there, I subtract 1, I get x minus 1. And then, when I take the square root, now I have what? X minus 1, the square root of that whole thing. That's it. So then g inverse of x is equal to the square root of x minus 1. That's it. So instead of having to go and write that y be equal to x, interchanging x and y, and then make y the subject, and then you write the inverse, you simply go from here straight to here. Why? Because it's a simple, it's a quadratic type of expression here, right? Well, function, I should say. Quadratic function, right? But on this side here, we have a quadratic expression, all right? And therefore, in order to make this here, in order to find the inverse, I just move from here straight to here. because it's simple enough. So let's assume that CXC, you know, will give you one like this, right? Follow me carefully. Let's suppose, which I doubt, of course, CXC, you know, what I ask you. Okay, given that f of x is equal to, given that f of x is equal to x minus 5. What are you going to put? Let y be equal to x minus 5 into changing x and y, and then, you know, you're going to make y the subject. When all you need to write is that f inverse of x is equal to x plus 5. So therefore, I would think that once you understand what you are doing, it is very simple to move from here straight to here. Right? Let's do just one more, just to make sure that you really understand. Right? Let's suppose h of x. Right? So, you know, we are given h of x this time equal to x minus 5 over 7. And you have to find h inverse of x. What is h inverse of x? Again, establish what is done first. Right? Read it out to yourself. X minus 5 all over 7. X minus 5 all over 7. So what is done first? We subtract 5. Then you know what we do next? We divide by 7. Yeah? So then if we are reversing it, we have to multiply by 7 here, and then we have to add 5 here. Simple? So therefore what? Starting with x multiplied by 7 is 7x. And then we add 5. So we get 7x plus 5. And that's your inverse. So simple and so straightforward. So what we are going to do now, because remember, I'm not really teaching this topic. If I was teaching the topic, I would have done a bit more, right? And of course, you know, I might have used some different functions to really test to see whether you really understand the thing. But because this is just an introduction, right, I am just going to just be touching on certain things. So let me now look at, you have to excuse me, sometimes these markers leave the board a bit dirty, so I have to use a cloth to give me a nice white board. I want you to be able to see exactly what's going on here. All right, so let's just look at something else. So let's look at anything divided by 0. Right? So if I were to write you on the board, what is 5 divided by 0? What would you tell me is the answer? Most of you, you know, were told by your teachers that anything divided by 0 is undefined. Right? You can't really find a value for it. Right? Sometimes they say it's indeterminate, sometimes they say infinity. So you know, they might use this nice symbol here. Let me make that a little nicer than that. Come on. Right. So that's my infinity. Sometimes it says undefined. So once you're dividing by 0, you should be thinking about this word here, undefined. Okay? Once you're talking about 0, you should be talking about undefined. Right? It will, you know, you will see this in functions, right? Where they ask you for what value of x is the function undefined. That means what value of x will cause the denominator to be 0. All right? So let's see. Why is 5 divided by 0 undefined? Have you ever wondered why? Why is it undefined? So let's see how we can make some sense out of this. All right? Why is 5 divided by 0 considered to be undefined? Now, let's first start to look at this here. What is 5 divided by 1? 5 divided by 1 is equal to 5. Being all of us supposed to know that, right? What is 5 divided by 0.1? 0.1, how do we do that? we say, okay, we multiply both numerator and denominator by 10. So we get 50 here, and we get 1 here. So 5 divided by 0.1 is 50. What about 5 divided by 0.01? This is equal to, again, multiply this by 100, so we get 500 over 1, so the answer is 500. What about 5 divided by 0.001? 5 divided by 0.001. What will that be equal to? That is equal to, again, multiply by 1,000 here, 1,000 here, so we get 5,000 over 1, which is 5,000. And if we were to go up here and we were to say, well, okay, what is 5 divided by? And we put 0.000001. So we have 1, 2, 3, 4, 5, 6. Like in this case here, we have 1, 2, 3, so we put 3 zeros here. 1, 2 decimal places, we put 2 zeros here. So the number of decimal places could give you an idea as to how many zeros we need to put. So therefore, this is equal to 5,000,000 divided by 1, right? So then, what are we observing? We are observing that by keeping the numerator constant, that means we're keeping it the same, and decreasing the numerator, right, by 10. When I say by 10, by 1/10, I should say, right? Decreasing it, we will have what? So therefore, this here is becoming 0.1, 0.01, 0.001, and so on and so on. So this denominator is getting smaller and smaller and smaller, closer and closer to 0. Because if I put 3 more zeros here, I will get what answer up here? I will get what? 5 billion. You see? If I put 3 more zeros down here. But of course, putting 3 more zeros here does not actually make it 0. Right? It will get closer and closer, we see. It's getting closer to 0. So as my denominator gets closer to 0, the result gets larger and larger and larger. So we see the result approaches what? Infinity. Right? It approaches infinity. Yeah? So, and this here simply means that it gets larger and larger and larger. So, therefore, anything divided by 0, you can't really find a value for it. It is said to be undefined. All right? So, again, you understand from this little analysis here why anything divided by 0 is considered to be undefined. We can't really find a value for it. All right? The last thing that I'm going to do now is kind of help you to understand. It's a simple topic, which is the interior angles of a triangle. I know that SCA students, I believe, will do this. I wonder how many of them really understand why that may be so. Right? How many of them really understand why that may be so? Why is the sum of the interior angles of a triangle equal to 180 degrees? So let's see. Let's see that quickly, and then, I will end this brief introduction of myself to you. Right. So if I were to draw a nice triangle here, nice large triangle, so that you can see what is being done, and I were to label this A, followed by B, followed by C, right? And I have here ABC. So let's call this the angle at B. We call this the angle at C. We call this the angle at A. Right? The interior angle, because we also have an exterior angle at A. Yeah? We also have an exterior angle here. We also have an exterior angle here. We also have an exterior angle there. So therefore, we have this A, angle A, plus angle B, plus angle C is equal to 180 degrees. Yeah? That's what we have been told. Here the question, why is that so? Why is the sum of these angles here equal to 180? And let me tell you this, once you understand mathematics, solving problems becomes second nature, easy. All right? So in order for me to establish this as to why this is so, right? And it's simple to already prove this actually, because you already have a lot of the knowledge of what is required to prove this. Let's see. All I have to do is extend this here, right? And simply draw a line, right? That passes through the apex here, right? The highest point of the triangle, which is A in this case here, and parallel to this line here. So let me just draw a line like that there, right? And I'm going to put an arrow on this here, and I'm going to put an arrow on this here to indicate that these two lines here are parallel. So anytime you see an arrow like this here, all it's telling you is that these two lines are parallel, and therefore now we can use all the rules and properties associated with parallel lines and angles. All right? So watch this. Okay, so I have here this angle here. Let's look at this angle and this angle here. All right? Now, of course, based on information that we know, what do we know? We know that, follow me carefully, that this angle here, and this is one perspective, these two angles here and this angle here, what we call interior angles. Right now, an interior angles add up to, or co-interior add up to 180 degrees. So, or we can look at it another way. Let's look at it another way. Let me just remove that A there and let me just extend this line a bit. Right? So if I extend that line there, I can also say, which might be easier for some of you to conceptualize, at this angle here and this angle here are actually equal angles. Co-interior angles add up to 180, they are supplementary. But these two angles here, what we call complementary angles, and they are actually equal. How do we know that? If I were to just do like this, and I were to cut this, let's suppose I have, this is drawn on a piece of paper, and I were to cut this along this line, which is parallel to these two lines here, and I take this here and I fit it nicely on this, you will see that the angles will be exactly the same. Right? So we call them, they correspond to each other. Right? This angle here and this angle here are what we call corresponding angles. So therefore they are equal. Now, watch this. Since these two angles here, right, are on a straight line, and we know what a straight line is. A straight line angle. A straight line angle is one that is equal to 180 degrees, right? For that straight angle, it's 180 degrees. So these two angles here must be 180. And these two must also be 180. So follow the logic. Since this here and this, right, together equals 180, and this also equal 180, what can we say about this angle here? You are correct. And this angle here must be equal to angle B. So in other words, these two angles here must be equal, and we can also see that from looking at our Z, which of course some teachers also like to use. So they say that this here will be equal to this here. Correct? You remember that from your teachers? To tell you that. But remember that when a teacher tells you that, you must be able to understand why that is so. And we could see that why that is so by looking at the fact that these two angles are corresponding. These two angles must add up to 180, right? Because they are a straight line. And similarly, these two angles add up to 180. So therefore, this here must be equal to this. Hence the reason why they are said to be alternating, right? Alternating angles. All right. So then, you know, we use the same principle, of course, on this side here. And we'll also get, if you look at this here now, right? We see that this here is the angle at C. So we see that this here must be equal to this here. So therefore, this must be equal to, right? And what do we have here with these triangles here? These triangles here together, if you check this here, going from here straight to here, that must be equal to what? 180 degrees, because these three form a straight angle. So therefore, we can write now that angle A plus angle B plus angle C must be equal to 180 degrees. Right? So that will help you to understand why that is 180. And then, of course, now, you know, we can extend this to a four-sided figure, right, which is called a quadrilateral. And therefore, the sum of the interior angles will be equal to 360. And then, of course, we can go up to a pentagon, hexagon, heptagon, etc., etc., etc. And we can develop now why the interior angles will follow this kind of pattern. You see, just by looking at the interior angles of basic triangle. Okay? So, I hope that we understand each other. And this basically is just a brief introduction of who I am, what I do, and how you can benefit from what I do. Okay? I will be, you know, as I said at the opening, right, having an extensive program, intensive, I should say, program for the Form 5 students who are preparing to write exams. Talking about, we're looking at past papers, we are going to be addressing, you know, how to answer the questions, right? And of course, those of you who may just need a little sharpening in some areas, we can help you to become as sharp as possible, right? Or I can help you to become as sharp as possible. Sorry. All right. So on pin.tt, I have an add up, and the price quoted is $550, and that $550 will be for 2.5 months, right? Which is from next week, because class will be starting next week, Saturday, right? Until the end of May, because exam starts in June. Okay, so that is roughly about 2.5 months, right? Let's suppose, you know, let's say about 225 per month, right? And therefore, you know, that's how I arrive at the figure of 550. So I hope to see as many of you as possible. You can call me at 388-8036, and we can discuss further. I look forward to seeing you, and do enjoy the rest of your day. Bye.